So we'll take a look at this first question here. The question's asking you to determine, let's go into black here, determine whether the following system has one solution, no solution, or infinitely many solutions. Okay, so the first thing we want to do is actually get an idea. Let's see if I can find here it is. This is where we are. Okay, what we can do is get an idea of what those might be. I'm going to do a whole new graph here. Get rid of these things. Sorry. Would have been faster to put in a new one. Okay. So what we have is we had two linear equations. So we'll give an example of a linear equation. Y equals mx plus b. Okay, and we'll put some variables in for them. So right now m is 1 and b is 1. So we have 1. And what this is a system of equations. So I'm going to put another one here. Y is equal to 4x plus 8, let's say. And you'll notice these two, they intersect at one point. So because they intersect at one point, they have one solution, essentially. But there's other options to this. So instead, we could have, we'll turn off this black one here. We could have infinitely many solutions. Infinitely many solutions would look like this. Y is equal to 2x plus 2. Sorry. Y plus 2. There we go. And if you notice that these two, they actually overlap each other. And because they overlap, essentially every single point along the continuum is a point of intersection. So we end up with infinitely many solutions. So what we have to do, and as you notice, this one, and since this is technically a 1 and a 1, and there's a 1 here, these are actually the same equation. So anytime you have the same equation, or the two equations are equal to each other, that means we'd have infinitely many solutions. And finally, another option is zero solutions. A zero solution could look like this. Y is equal to x plus 4. And what you'll notice here is that these are both parallel. And because they're parallel, that means they're never going to touch each other, so there are zero solutions to this answer. And another way you can tell that is if the slopes, in this case this is 1, these slopes are the same, but the y-intercept, which is b, are different, that means they'll never intersect with each other. Okay, so with that being said, let's jump back. Oh, I've lost it. All right, you got to find it. There it is. We've got to talk about these questions here. So where you got to decide, or we have to figure out if these two are the same, different, or they have the same slope but different y-intercepts. So what we can do is we can take a look at these and try to reduce them. So looking at the first one, that doesn't look like there's a common factor. So we're going to look for a common factor, or the best one would be the LCF, the lowest common factor, but it doesn't look like it has the lowest common factor. So we're just going to leave that one as is. This one here, we're going to reduce with the lowest common factor. And we may not find the lowest one off the bat, so we can start with, I can tell 4 goes into this. So if I divide each of these by 4, okay, we'll still get the same linear equation, but it'll just be in a reduced manner. So 8 divided by 4 gives us 2x. 20 divided by 4 is 5y. And 44 divided by 4 is 11. Now when we look at that, that means this equation is the same as that equation. If the two equations are the same, that means we're going to get infinitely many solutions to this question. Oops.